Okay, welcome back. Today we're going to do another short video on the intermediate value theorem. So I'm going to introduce the intermediate value theorem and explain how it works, and then what we'll do is we'll do an example or two afterwards. Okay? So in this here, the intermediate value theorem is a really neat theorem that allows us to be able to show or determine whether there exists a zero in between two numbers on a graph. So we're talking about an interval on the x-axis. Okay, so if we know certain conditions on a particular interval, then we can say by the intermediate value theorem that there has to exist at least one real zero in between the two numbers. So how does it work? Okay, so the intermediate value theorem states that if f of x is a polynomial function with only real coefficients, and if for real numbers a and b, so this is on the x-axis, so real numbers x equals a and b, the values f of a and f of b are of opposite in sign. So they have opposite signs. Okay? So let me just repeat that. If we have a function, a polynomial function with only real coefficients, and if for real numbers a and b, so on some interval a and b, that the value of the function f of a and f of b have opposite signs, so one's positive and one's negative. If that's true, then there must exist at least one. So there must exist at least one real zero between a and b on the number line. Okay, so in other words, if you look at it this way, and we draw a graph, okay, and let's say we have a function that does something like that, okay, then what they're saying is if we take an interval, let's say from here to here. Okay, so here's our A and here's our B. And so if we take some interval, right, from A to B, and we take the value of that function, right here on the graph, and so we know the value of that function is going to be, oops, let me do it this way, f of a, and then we have another value for b here, so here's f of b, right? So we notice that in this example here, this f of a is negative, it's below the x-axis, right? And this f of b is above the x-axis, so it's positive, so we see that both of these values of f of x are opposite in sign, right? So one is above the x-axis, one is below the x-axis. So what is the intermediate value theorem saying? Well, the intermediate value theorem is saying that, hey, if that's true, so we've got an interval from a to b where the f of a and f of b have opposite signs, which means the graph is below the x-axis at one point and above the x-axis at another point, that means that there must be a point in between, right, some point C, where it crosses the x-axis, where it's equal to 0. Okay? So there must be a real zero here. Because remember, we're talking about a polynomial function. Polynomial functions are what? Continuous, it's smooth, right? There's no jumps, breaks, or holes in the graph. So if the graph of the function is below the x-axis at one endpoint on an interval and is above the x-axis at another point at the other endpoint of the interval, then it stands to reason that the graph must cross the x-axis somewhere. That's what the intermediate value theorem is saying. So there must be a real zero at some number c, right? At some number c, there should be where the f of c is equal to 0. Okay? And that's what the intermediate value theorem is stating. Now, what we can't do is, what if there is no sign change? What if we pick an interval and f of a and f of b have the same sign? Well, in that case, the intermediate value theorem is inconclusive. We just don't know. Okay? So be careful. If there's a sign change, if these conditions are met, then what the intermediate value theorem is saying, there must be a 0 in between the two. So if f of a and f of b have opposite sign, then there must be a 0 in between those two values. In other words, there must be a value c where f of c is equal to 0. Now, if there is no sign change, then we don't know. We can't say one way or the other. Okay? So that's it. That's the intermediate value theorem. So what we're going to do is we're going to do an example or two and show how this works. Okay? Have a great day.